Okay, with cosecant and secant graphs, I revert back to sine and cosine. Okay, because we're going to see the same kinds of things happen with these two graphs as with the tangent and the cotangent. So wherever the tangent was 0, the cotangent was undefined and we had a vertical asymptote. The same thing happens with secant and cosecant. So since cosecant is the reciprocal of sine, everywhere that sine is equal to 0, cosecant has a asymptote. Okay, so I guess we could look at our unit circle, or we could look at the graph of a sine function. Let's just go off of a graph of a sine function. So over here, I'm just going to do a real basic, no frills sketch. Okay, so sine starts at 0. One period is 2 pi. So it goes up, comes down, goes down. Okay, so sine intersects the x-axis at 0, at pi, and at 2 pi. Okay, so sine of 0 is 0. Okay, so sine of 0 is 0. So that means the cosecant of 0 is 1 over 0, or it's undefined. Okay, reciprocal of 0, there isn't such a thing, it's undefined. So cosecant is going to have an asymptote at 0. Okay, well, sine of pi is also 0. So same thing's going to happen there. So cosecant of pi, what's the reciprocal of 0? There isn't one. It's undefined. So cosecant is going to have a vertical asymptote at pi. Okay, same thing's going to happen at 2 pi. Sine is 0 at 2 pi, but if I flip that, then I am now undefined at 2 pi. Okay, so you can tell that there are asymptotes at every pi interval. So I can sketch in some other asymptotes. Okay, now the other thing that happens is wherever you have a high point on a sine curve is going to be a low point on a secant curve. Everywhere you have a low point on a sine curve, you're going to have a high point on a secant curve. So you can go through and you can plot points. Again, I'm going to piggyback off of a sine curve. So my sine curve, let's see, yeah. Okay, my sine curve goes up to 1, comes back down to pi, comes down to -1, goes back up to +1, comes down, okay, does the same thing over here. Okay, up and down, up and down. Okay, so your your cosecant, wherever your high point is on your sine, that is a low point on a secant, and my secant opens up like this, and it's going to follow along those vertical asymptotes. Where you have a low point at sine, your secant opens down. Okay, high point on sine, secant opens up. Secant looks like a bunch of parabolas is what it really looks like. And then it's going to open down. And then here, open down, here, open up. So basically, your secant is like sitting on your sine and your cosine. Okay. Then secant works similarly, except with cosine. So same kind of thing. If cosine, okay, so again, cosine starts at 1, and then this period is 2 pi. So starts at 1, and it's going to go down here. It's going to come back up, and there's one cycle of your cosine. So same thing, 3 pi, it'll go down, come there, come back up, go there. Okay. Okay, and then it's going to do one to the left. Okay, and there's that. Okay, so that gives you kind of that sign. So same thing's going to happen with secant. Everywhere where cosine is 0, okay, which would be like at pi over 2, negative pi over 2, your secant is going to have asymptotes. Okay, and then it crosses here, crosses here, this is here. Okay. And then it does the same thing as what the cosecant does. So basically your high points and your low points for your cosine are going to give you the maximums and minimums of this secant graph. And again, it just looks like a bunch of parabolas. One parabola opening up, the next one opening down, and it just follows that pattern. And that is what a secant curve looks like. Okay, so your cosecant and your secant curve really look very, very similar. They're just a kind of a shift, horizontal shift. If you shift one over, it'll match up with the other one. Same way with your sine and cosine. If you shift the cosine over, pi over 2, it's going to match up and it's going to look like a sine curve. Okay, so really, that's how I graph secant and cosecant. So I think about the same thing as a sine or a cosine, and then I sketch in my asymptotes and then find your high points and low points, and then that's where your parabolas are going to sit. Okay, now we can write out here, for example, so y equals a cosecant of b times theta minus c plus d. Again, same thing happens. Your period for your cosecant is 2 pi divided by b. C is your horizontal shift. D is your vertical shift. And then to find your asymptotes, you are going to solve x equals, your asymptotes are going to be at x equals n times pi. So 1 times pi, 2 times pi, 3 times pi. Okay, and that's how you can find your asymptotes for the cosecant. Okay, for the secant, same thing. B times theta minus c plus d. So again, your period is going to be 2 pi divided by b. C is going to give you a horizontal shift. D is going to give you a vertical shift. And to find your asymptotes, you are going to do x equals pi over 2 plus n pi. Okay, so pi over 2 plus n pi. So pi over 2 plus 1 pi. So at 1.5 pi, you have an asymptote. Okay, pi over 2 plus 2 pi. So at 2.5 pi, you have an asymptote. Again, you can graph these on your calculator. You're going to use a similar window as to what we were working with sine and cosine. So you can graph those. Okay, so in class, we're going to do a little bit with Desmos so you can kind of see how these graphs work. And as you manipulate your numbers and change the period and things like that, what your graph looks like.